Hey everybody, this is Larry. This is Leetcode Weekly Contest 191, the 191st. Anyway, hit the like button, hit the subscribe button. Let me know what you think. This is my screencast. The explanations will be so usually I go over the problem as I solve them, and then at the end there'll be an explanation. Wish me good luck. I would you like to use good luck? Hope you had a good contest. Hope you did run everything. Anyway, let's get started. Jeez. And here we go. Q1, maximum product of two elements in an array. So this one is just greedy. I think when I first opened this problem, I was deciding between two solutions, basically the brute force n square one, and whether I could do sorting. Um, the sorting one has more edge cases if the numbers could be negative, but I think I checked that the numbers could be only be positive, and then I was like, okay, off we go. So we just sort, and then we ran away with it. We sort, and we took the two biggest number, and then we just multiply it. So that's greedy in that way. And then I submit pretty quickly after that. Q2, maximum area of a piece of cake after horizontal and vertical cuts. So this one is basically you have some cuts, and then after you're cutting them, you try to find the biggest slice of each one, right? So from here, you could recognize, from here, and the explanation will be later on, feel free to skip ahead. But basically what I recognized was that, okay, you can always choose the biggest cut in the dimension. It doesn't have to be vertical or horizontal. So you just greedily do them independently of each other. And that way you just go straight from that sense. You sort the vertical and then you sort the horizontal cuts. So I was just also double checking whether we can put, so another way to think about this problem is that I put in Sentinels where there's a cut on 0 and a cut on H, a cut on 0 and a cut on W, right? So that's what I'm doing here. So I just put it in so that I can later sort and then look at adjacent elements so that you don't have to worry about edge cases with like the first element and then the last element or something like that. So that's what I do here. Um, I have a little bit of a typo here, and that cost me a couple of minutes because um, I think I confused horizontal cuts with H. So I knew that if you cut on the H, it goes the other way, right, or something like that. I was very confused, so I just got the signs wrong. But I fixed this later. There is another mistake, unfortunately, because I while I was double checking this, I forgot that you have to mod this because it doesn't seem like that because everything should fit in a long. So I did not um, think to mod it, but that cost me 5 minutes. So that was the wrong answer for this problem. But otherwise, I did this one pretty quickly. I wish they just give you one answer. Why make it a trick? It's Q2. Why make mod like a test case thing that you fail on? Yeah, but I looked at this. I was like, oh, this is the wrong answer. And I double checked to make sure that my understanding is correct. And then I was like, oh, it's probably because I mixed up the H and the W. And once I fixed that, I submit, but it was the wrong answer because I forgot the mod. Um, I, sad face. Oh, oh, oh. And then as soon as I saw it, I knew it. Also, at this time, I don't know what's running on my computer, but it was really running slowly. So I had to close some windows real quick. And that also cost me some time. That's what I was doing now. Because normally I would copy and paste this straight. Computer's really slow. and then just run it again because that's my usual pattern. But yeah, now I'm just closing some windows, and that took some time. Next time I should be prepared on closing everything first. But yeah, see now I went again just to make sure I get the right wrong answer. And then I was like, oh yeah, the mod. I knew about the mod because I remember reading it, so I knew how how I need to solve this immediately. But it was just sad. I was going to just copy and paste, but they used the same constant, so I didn't have to. Run it real quick. There's some lag because my computer is slow today. I really need to close some windows. But look at this. It's not even rendering. But okay, once I see that it gets the correct answer, I submit. And I think I also close more windows now. But yeah, so that's Q3. Or Q2, sorry. Q3, reorder routes to make all paths lead to zero. So this one, I like Q3 a lot, actually, this problem. Um, but basically, you have, and the first thing that I look for is just making sure that it's a tree, because I think, so I scanned this problem really quickly and when I was like, okay, I have an idea on how to solve this with depth first search or something, but I have to make sure that it's a tree first, because if it's not a tree, then I don't know, there might be cycles, right? That's one of the properties of a tree is that it doesn't have cycles. And then and because it's a tree, I think I looked at connections.length because you go to n minus one. That means that the number of edges is you go to n minus one. Then I know that um, I could do it with that first search. And what I did was, well, first I converted to adjacency list, as you see here. This is very basic adjacency list. I thought about which way that it should go because I was thinking that maybe we should go from 0 to whatever the number is instead. But yeah, but I was like, no, let's just create the actual adjacency list first. So while I was doing that, I thought about adding the weights. These weights don't make sense right now. I just wanted something as a placeholder. So yeah. So I have this base case where if node is equal to 0, we return. This doesn't really make sense because I changed. So my base case was going to be that for every node, try to go to node 0 and then change paths along the way. But I think I changed the way that I was thinking as I was typing it, but then I didn't change the base case, so it doesn't really make sense. But yeah, but basically the idea of what I'm doing now is just trying to figure out. So what am I doing with direction? The direction is how I count the edges that are going the wrong way, if you will. So if an edge is going the wrong way, and we go from 0 to that edge, or going through an edge that's going the wrong way, then we add 1 to the count. And because this is a tree, I'm able to just do this naive counting thing, and this is mostly right, I think, except for that I have the wrong base case of node is equal to 0. And I will explain this a little bit in the explanation section, so don't worry. But that's basically what I did. I was like, oh, wait, did I have the edges the wrong way? Because I wasn't sure about which way to put the weight on, even though I knew that's how it was going to go, because I just wasn't thinking about it. But I was like, still 0, huh? And then I had to add some print statement. But at the end of the day, the reason why this is wrong is because I had the wrong base case, because I was still in my initial mindset of going from other node to the 0 node as kind of given in the problem. But then I was like, oh, I could just go from 0 node to other nodes. And I was like, is my JSON list wrong? This looks pretty okay. But yeah, so this took me a couple of minutes as well. So not a smooth contest. And then when I saw that, I was like, oh, okay, let's run it. I do not get the right answer. So let's put the weight on the thing. I still don't get the right answer because I have a typo on, see if you could spot it. But that after I fix the typo, that's pretty much it. And making sure that the one is the right price. But a lot of sluggishness because I'm blaming it on waking up early, uh, but still, like these are just silly mistakes. Get the wrong answer, but that's okay. I was like, oh, that's just literally the opposite of what we need, so that's okay. And I submit, and I'm good. Q4, probably of two boxes having the same number of distinct bars. So this one, I think I read through it. There's no way I possibly read this quickly, right? But I scanned it, and that's why I solved the wrong problem for the first half an hour or so. Um, but yeah, so basically what I was trying to do was solve the problem where I mean, I think I did actually read it correctly at some point, but I had a mistaken either reduction or whatever you want to call it, but just in my head where I thought that you could narrow it down to for each bore, it has to be in bucket A or bucket B, right? And that's 50% chance of bore being in A, 50% chance of being in B, and then you just, let it be, right? Um, and I did some optimizations as a result that didn't really make sense. But the reason why that doesn't work is because at the end you need both boxes to have the same number of bars. But I did not realize this at the time. I was just doing math in a really hacky way, and I was looking at the constraints here now just to make sure that if I do DP in a weird way, I can do it. And immediately I break out my LRU cache for the something. But yeah, so now initially I have my indexes as A and B. I because I so index is the index of the Bohr's index. But the reason why I have it structured like this is because I just didn't like maybe I read it, but I didn't really understood it that um, bucket A of number of Bohr's in A has to be equal to the number of Bohr's in B. Uh, that's the problem. And here I just wanted to I have to look this up later, but I have to look this up later. But basically, I remember there's a way to. I thought there was a way that you can do, or in Python there's a binomial formula which is n choose r, um, and there probably is, but so I'll have to look it up later. It's just that I couldn't find it at the time, so I end up implementing it myself, and I spent some time debugging that because I had a typo. Such as life. Like I said, it's actually kind of a very sluggish day. A lot of silly mistakes that yeah, I don't know. But yeah, but now basically what I'm saying is if A is equal to B, we return 1. otherwise return 0, where the number of distinct things are equal to each other. And the recurrence here is just for each Bohr index, we try to, each Bohr index have 6 Bohrs, right? So we try to put, okay, that's what happens if we put 0 Bohrs in A and 6 Bohrs in B? What happens when we try to put 1 Bohr in A and 5 Bohrs in B, and so forth? So that's kind of my strategy here. And then I count the number of ways that you can do that, basically, with binomial function. Yeah, now I'm just writing the choice function, which ends up taking me a couple more minutes, which is kind of sad because this really should have been really quick. And I have a typo there, so there's just a lot of debugging. And I wasn't even debugging the right code. That's the kind of annoying part, is that I was debugging code that isn't, that I don't use later, is what I mean, right? Um, and that kind of wasted a lot of time for me. Um, there is a world though where this is right, or for a different problem this is right, and I would have gotten it really quickly. So sometimes you win, sometimes you don't. Sometimes you do well, sometimes you do. Because even if I submitted now, I would have been like, well, plus the 5 minutes, but I would have been like top 10 if I finished now. So I think excuse me. So I think in theory, if I had finished now, if this was the result, because I misread or just misunderstood the shuffling, then I would have been pretty much good to go. This is wrong, of course, because I got the choice wrong because I have a typo on the choice, which is kind of really sad, because that's just like, I should have just wrote factorial. Maybe that would have been more obvious. Instead of writing 3 for loops. I was thinking of just debugging our choice function by printing it out. I was like, nah, that looks right. But it was wrong. But I thought that looked right. That's why at the time I was kind of weird. But yeah, now I'm just debugging here, and I was like, wait, this doesn't make sense, and then I eventually have to figure it out. Just a lot of debugging because it's one of those blind spots where you win something enough times that you because when you do debugging, you debug the parts of the code that you think is the most risky, obviously, right? And for me, I just was like, this should be right. What is going on? Uh, and I end up spending like 2 minutes debugging something that isn't even right. Yeah, here I spotted the why it was. Oh, I spotted that it printed the wrong thing, and I was like, why is this printing the wrong thing? Like I don't understand it. And then I finally got to look at the code again. I mean, I did look at. I don't know. I keep on looking at it, but I just didn't get it. One of those days, I suppose. Okay. So that took 5 minutes just debugging, which is kind of that function. So that's sad. But so the answer is wrong, and I start trying to hack around this, which is a really dubious path. But like I said, the reason why this is wrong is because I looked at each 4 and I thought that it could be in A and B, and here I was like, oh, shuffled uniformly at random, right? So I was like, ah, I wasted 10 minutes on the wrong problem. I think I even mentioned that. The other person, Larry, mentions it now. But, oh man, I solved the wrong problem. Sad face. Um, then refreshed. I was like, oh, only 4 people solved it. So I actually have a good amount of time. Uh, and also that it's solvable. But yeah, now I'm trying to just actually think about how to attack this problem. Uh, and unfortunately, I went down the path of like, okay, let's just count the. I knew what I wanted to do, but I was doing it in a wrong way, like logically. And what I mean by that, I was from here, I was trying to figure out like, okay, let's only count the paths that are possible, and then go down that way. It's the type of subproblems. So and that's basically what I was trying to figure out ways to kind of play around it. It's unfortunately. Yeah, I'm just and here. I was just, I think I was still in the mindset of hacking the current solution to make it fit. Um, yeah, and that's pretty much. I think of like, okay, what if but at the end of the day, I did not really need to do that. I think I just need a restart. So I'm going to skip ahead. I mean, feel free to stay here or watch it on 2x or something. But all this until the next marker. Read, click on the description or the timeline thing, and yeah, I'll get right back to you. But that's when I finally solved the problem a little bit better. Well, I know it's wrong. I'm dumb. I'm here again. But yeah, but basically what you're watching is me not giving up, but giving up on this way of solving it. I was like, okay, Larry, first principles. What do you want? What are you trying to get? What are you trying to solve? And how are you going to attack it? I said, okay, there are only 48 bars. Let's let's put it in, right? Let's just expand it out so I could write the formulas a little bit easier because I think I was getting confused at some point. And here I'm like trying to think about what I could reuse and what I could use for this problem still. But here I already, resolved to kind of restarting it. And it's remarkable somewhat. I mean, and that's the thing about grinding. I kind of keep on focusing and keep on working hard on these problems. Sometimes it works, sometimes it doesn't, but you always learn a little bit more about the problem. And even though I did solve the problem the wrong way, I was able to kind of have a better understanding of a problem than I would have otherwise, obviously. I mean, I knew what not to do now, right? but but yeah. So I finally reduced the formula to instead of kind of putting together. So what I was trying to do before for 20 minutes or something like that was I was trying to combine the numerator and the denominator in a way, thinking that they're independent of each other. And there might be actually a way to do it, but my math was not strong enough to do it that way. So what I was like, okay, actually, what I'm really actually wanting to do is just count the number of ways that um, count the number of ways such that our constraint works, which we could use DP, and count the number of ways in which a looser constraint, of which is a possibility but false. So basically, you have three ways of. I was kind of thinking about it during before, but I was trying to merge them together in a way that I couldn't get it to work. But basically, what you could think about it is that each state, if you will, have three different possibilities, right? One is it could be true, meaning it is a valid end sequence, and yeah, that is a valid end sequence, and that yeah, and that's just one of the possibilities that you count positively, right? And then the second possibility is that it is false, but it still counts as a possibility of some a sequence that you can generate, except for that it will count as zero, right? And then the third is just that it's not a possible, feasible possibility. So in that case, I wrote a count which counts the numerator, which means all the good ones, all the numbers that are given to us, and then the denominator, which just counts the total number of sets that we can be possible, but even the ones that we don't want. So basically, we have the things that we want on top, and then the things that the combination of things that are possible on the bottom, and we both do a DP for that, and then we solve it that way. That's pretty much it. And the denominator, of course, is actually you could prove that to be n choose n over 2. But I wasn't thinking about it, and I was a little bit copy and pasty because you could see it because, but I mean, that's just the way I did it. So you may wonder why that this runs in time. The reason is that even though I have extra dimensions, and this is why it's required to do the analysis, complexity analysis, is that even though I have extra dimensions, the extra dimensions, they depend on each other. So all these dimensions are not exactly independent. And because I did it top down with LRU cache, it doesn't create an entry for all the possible states. It only create an entry for the states that you visited, right? And because those visited states are not the exhaustive number of possibilities, that's how it gets it into running time. Even though that's, at the time I didn't know that, I just kind of submit YOLO. So this is pretty much it. I had a So unfortunately, I have a typo that I still spent a couple more minutes to debug. So it's just a lot of typo filled day. It's very frustrating looking back because like I have the right ideas in a lot of places, not this one, but in a lot of places, but I just have the wrong idea. And this is also something that is what happens when you copy and paste. So kids don't copy and paste, but that's what I did anyway. So maybe I'm a hypocrite for that particular one. But once you do that, once I figure out the typo, I submit and it was good and I was happy. Cool. Hang out with the other Larry. He'll start talking soon, and I will see you later. Bye bye. Hang out with him. Let me know what you did. Oh, not silly mistakes, but that's okay. I was reading the wrong problem and I got stuck in solving the wrong problem. Um, Also, this one was just dumb, but everything else I got stuck solving the wrong problem on the Q4. Um, that's what's tricky about these dynamic programming. It's that sometimes you just solve the wrong, you misread it a little bit and you solve the wrong one. Um, After I reset, and I think the problem is also sometimes you get stuck in a mindset of this is how I should have solved it, and there's some way I could hack around it, but you and it took me a long time on this problem, but sometimes you just need to reset and be like, okay, how do I actually solve this problem? And then start again. And that's basically what I did, and that was okay. And it doesn't seem like I'm going to not finish in the top 100 or maybe barely finish in the top 100 because of the penalty. The penalty was kind of dumb. That was a little, because I read it and I knew it, but then I just didn't get it. But that was a hard one. But Chip still gotten it. I just, like I said, I got stuck on thinking about it one particular way, and I was like, nope, I don't think you could do it that way. And I was trying to hack it, but yeah, um, man. Ugh. But yeah, I feel a little sad because I don't know. I guess I'll watch the tapes later to kind of see where I got done. Let's go over the problems now. Maximum product of two elements in array, Q1. So yeah, so this one I just did it greedy. I just sorted the array, and I take uh, the biggest number, and then the second biggest number, subtract one, and then multiply them. The thing that I did look for was to make sure that these are positive numbers. Because if you have negative numbers, this won't work. But as soon as I saw that it is positive, then I just did it and it'll be okay. You could have also just did it with 2 for loops because n is equal to 500. Maybe I should have done it that way just because that would have been less thinking slightly. But I got it in about a minute, so I'm okay on this particular problem. But yeah, but you could do brute force. I did it with sorting and choosing the maximal elements. Cool. This is a straightforward problem. This is n log n because I dominate, or you get that's dominated by the sort. But you could probably, in theory, quote unquote, write a linear time algorithm based on the fact that numbers can only go up to 1,000 or something like that, right? So, but I think that's kind of half cheating, so whatever. Or like, that's the size of your domain rather than linear per se. But yeah, straightforward problem. Cool. Q2, maximum area of a piece of cake after horizontal and vertical cuts. So this one I did pretty straightforward. I spent 4 minutes because I think I was mixing up the H and the W. I wasn't sure that horizontal cut, I guess makes sense. I think I got a little bit confused about H in the horizontal, to be honest. And then I confused it with height because I was like, now, if it's H, then you want to cut, because if you cut height, you cut the other way, something like that. So I mixed up these two variables. So that threw me off for like a couple of seconds. And I was like, okay, maybe that's wrong. But the idea here is that the dimensions, the vertical and horizontal, they're independent of each other. And what I mean by that is that you could use greed. And what I mean by that is that you could choose the widest or the longest on the height or the width, and then you take the longer. You always choose the maximal version of that. And once you do that, you just multiply them together. I think this one was kind of annoying because the modulo stuff. I mean, I think they really could have just made this slightly smaller so that it doesn't have to require modulo, because it also fits in a 64-bit int. So that's why in a moment I forgot about the mod and I got a wrong answer, if you recall. But I actually, I mean, when I saw it, when I first read the question, I did see this, and usually I would immediately go down to the solution and write down the mod. But this problem, I guess I was a little bit rusty and not cohering to my usual thing. But yeah, but basically I just take, I sort the cuts, and I take the two adjacent cut where you cut it, and then you just take the fattest piece of both the width and then the height, and then you just time them, multiply them together to get the result of the biggest slice. Yeah. So this algorithm, the way that I did it is O of n log n dominated by the sort. That's pretty much it. The space is also O of n, the way we did it, kind of, depending on how, if you want to count us modifying the inputs. But yeah. Cool. Okay. Q3, reorder routes to make all paths lead to city 0. So this one, the first thing that I looked for was making sure that it's a tree. And now, once I made sure that it's a tree, I think the confusing thing might be that you notice that it goes from, you want to start at or you have a node 0 that you want to get to, but all the edges are going the wrong way, possibly, or some of the edges are going the wrong way, right? So what I did was that I took a minute to revert how I was thinking about the problem, and then and instead of solving the problem where all the edges faces 0, you solve the problem where all the edges were or you solve the problem where all the edges are going away from 0 and then minus n or something like that. I did it the other way where I constructed a graph where there's a weight on the graph on traversal. That means that for every edge that goes from U to V, every connection here, and you might have to read the problem. I think I end up just testing which one works because it's always a little confusing which direction the connection goes sometimes on these problems for me. So, and the one edge means that that's the cost of traversing from that edge, right? And that means, in a way, what I was trying to say is that this cost of doing this depth first search means that it's the cost of flipping this edge. And if you're going from 0, that means that if an edge is already facing towards 0, then it's good. That's why it sounds counterintuitive that my list is given that V to U has a 0 cost. But because if it's going the other way, where 0 goes to 1, for example, then you go from 0 to 1, that means that you actually want to flip that edge, because that's the only way to go from 0, so that the one edge points to 0. So then that's why I have a weight here. And then I just sum up all the weights, and that is my answer for Q3. As this is a depth first search, and there's no sorting or anything, this is all V plus E time. And of course, it's a tree, so it's all V times. And space is all V as well for the adjacency list, because the list is the number of edges is just the number of vertices minus 1, right? So yeah, that's Q3. Yeah, Q4. Whew. Yeah, Q4 was really tricky. I solved the wrong problem in that I thought I just misread the problem for a long time, and I was trying to hack it. That if you look at my if you watch what I did, that's basically what I did. But basically, the problem that I initially tried to solve, and that's what's tricky about these probability questions, is that you really have to get the denominator right. So it's not, because a lot of the times when the similar problem is you have to count, and the count is just counting, just counting something, and it's very obvious how you count, because you only have these conditions, and you're trying to meet these conditions with dynamic programming. I'm hand waving a little bit, and it's not as easy as it sounds, but it's the easier version of this problem, is what I'm trying to say. But for this problem, so what I thought I read was that for each Bohr in Bohrs, or for each Bohr, you can be anywhere. Also, that's so that means that all the Bohrs could be on the left bucket box, and all the Bohrs could be on the right box, for example. So it took me it took way too long for me to reread this problem to understand that actually it's shuffled randomly, right? Or shuffled uniformly. So that means that the left box has to have the same Bohrs as the right box. And I did read it at some point, but it took me, and I was unfortunately stuck in a mindset where I was trying to hack the solutions that I had into this solution, and I couldn't really get it to work, as you saw, and I ultimately did not get that to work. Maybe I could get it to work, but I don't know. Maybe my optimism was what the issue was. But what I end up doing was basically just getting the numerator and the denominator separately. The numerator, we know that it's basically just the number of counts where this is valid, where you do have where CA is equal to CB, meaning the number of Bohrs in both boxes are the same, and that they have the same number of distinct Bohrs. And that's I did that with a bit mask ultimately, but you probably could have been a little bit smarter. And I also converted it from Bohrs to labels to kind of just make it simpler for me to do this recurrence. And then the total, actually, I mean, and I actually recognized this as I was doing it, but I didn't want to, I don't know, I was trying to save time, to be honest, so I was a little bit copy-pasty. So this is actually way more states than necessary, but it's okay. It's still bounded by the same complexity, because it's the same complexity as count anyway. But basically, you don't even need A and B. These are unnecessary inputs. So you could have done something like this, and basically what this is saying is, give me the total number of cases where CA and CB has the same boxes. And actually, if if I had took the time to think about it, it's just N, it's just this N, choose CA or CB because they're the same. But so that's just N choose CA, but I was really trying to think from first principles instead of trying to reprove everything. Hey, what is the total number of possible moves, even invalid ones, where CA is due to CP? So that's kind of how I got this recurrence from first principles. A little copy and paste before, even though that's just n choose CA. And when I got that actually now that I think it through this way, it's actually kind of much easier, and I should have gotten it much faster. But part of that is that I misread the problem, and sometimes misreading or no misreading, it is very hard to let go of an approach that you're confident about, even if it's wrong. But take the time to sometimes step back and start everything from scratch. I mean, not literally everything from scratch, but like mentally from scratch. And that's what I was forced to do, and that's what I did, and that's how I solved this problem. And actually, now that I phrased it the way that I just did, it seems to be a much easier problem. But in terms of just the numerator over denominator, but the way that I started approaching it with dynamic programming, and because there is a class of problems of dynamic programming where it is a probability based, with each state having effect, like with each state being a subproblem. And here I defined it a little bit incorrectly of the DP. So, oh well, not a big deal. Let's see how I did this contest. Oh, let me analyze this first, sorry. So what is the complexity of this, right? Well, A could be up to 2 to the 8. That's what I notice here, right? B could be 2 to the 8 as well. So that's 2 to the 16. Index is 48, because that's just the sum of 6 times, that's just 6 times 8. CA could be 48 and 48. So that's kind of the complexity. Actually, that seems a little high. I guess maybe I got a little lucky with that. A lot of the states are not reachable, or something like that. Or maybe the test cases are a little weak, because if I had actually done the math, but I thought this would be good enough. But yeah, but A is basically the bit mask for all the things. So yeah, so this is all of. Let's give some variables. I could say this easier, right? N is equal to total number of balls. K is equal to number of different type of balls. Then this is just K, 2 to the K times 2 to the K times this is 48. So these are both 48s. So actually, you could have bounded this by half just by saying that if CA is bigger than n over 2 or something like that, right? But yeah, so that's my complexity, n cubed times 2 to the k plus 1. So I am actually surprised that passed, but that's it. Yeah, and that's pretty much my complexity. My space is similar because exactly the same in the big O notation, because we only do two constant operations for this one. But yeah, that's all I have for this problem, I think. Cool. Let me know what you think. Because this is a little bit of a tricky problem, so I might explain a little bit more. But the idea is basically the recurrence. But okay, let me recap this problem. So how do you solve this problem? The recap is just find the numerator and the denominator. The total number of possible shuffles. It requires the number of balls in box 1 and the number of balls in box 2 to be the same. So this should be just n choose n over 2, which is what this recurrence does in a really unnecessary, right? And then the number of count of boxes where they have the same number of distinct So the numerator is the count of the number of possibilities where they have the same number of distinct bars, type of bars, right? And that's what this function does. It counts. I have this thing that counts the number of things in a bit mask, and then it just does this recurrence of, okay, let's put the ball in A. And then let's put the ball in B. And then what happens when you put the ball in A, and what happens when you put the ball in B? And then at the very end, just make it 0. Just count the number of total numbers in that result. But yeah, just want to add a little bit to the analysis of the complexity of to analyze this one. So one thing that I did not do during the contest, and I'm very fortunate that it passed. Well, it's a weird way, right? Because it's that, as we talked about, I want to reiterate. So the way that you can analyze this state, right, is that, well, how many possible things are there for index? Well, it's just 48. So it's O of n times C, where C is the max element of A sub I or ball sub I. And n is equal to the total number of balls. And k is equal to the number of distinct balls. So this complexity would be, index would be n times c. No, sorry. Index can be just n. A is 2 to the k. B is 2 to the k. CA could be n. And CB could be n, right? So on a really naive analysis, which I did, that's why I'm supplementing, is that this is the complexity, right? And you could do that, and this is just, of course, 2 to the k times 2, right? And you may wonder, how does this run in time, right? Well, it turns out, and this is the one thing that is sometimes good with top-down memorization if you do it correctly, is that you don't explore all the states. And one thing that what happens is that a lot of these states are not visited, and you wonder why. How can they not be visited? Well, the thing is that, for example, CB depends entirely on CA, right? And what I mean by that is that for every index, for every number on index, let's say, well, for every number in index is essentially equal to CA plus CB, right? So basically what I'm saying here, even though I didn't notice this at the time, I mean, I was trying to rush it a little bit too much, and I did a few things. So I didn't recognize this at the time, because usually I would have to make this optimization, but I rushed it, and I didn't even realize that was too much, because if I did that, I wouldn't have done it. And you could have easily just written, you could have optimized this by doing this minus CA, and then remove that from the input. And that would save you a little bit of space, for example. But because this is the case, the real complexity is this, n squared times 2 to the k times 2. And of course, CA is less than index, so there's some symmetry, so that you can divide it by 2 or something like that for more actual time performance, like tighter performance analysis. But yeah, I just want to point out, this out because this may look confusing. Like, wow, n cubed times this whole thing. That is way too big. And you are right. So yeah. Yeah, that's I just wanted to add that so that you have another thing to add to your toolbox in terms of analysis. Anyway, back to your schedule thing. That's all I have for this problem. So let's kind of see where I end up at. Top 100, I guess that's okay. In retrospect, I should have done it faster. And also this 5 minutes was kind of sad because, let's see. If I didn't, I would have been 60. I guess that's still pretty okay, but not but a lot of people got that. I feel like a lot of people got the same exact mistake. So I think like on that ground, like a lot of people have even grounds. Um, like I still could have done the last one faster. It's just that it took me a long time to pivot. Because I think as soon as you saw me change the way I did it, I got it in like 3-4 minutes, maybe a little bit longer, but not that much longer. I mean, I understand that a lot of the work is to figure that out and exploratory, but in terms of actual implementation, it was pretty simple. In theory, yeah, maybe more practice, maybe with probability problems, I could have done a little bit better, but that's okay. I think this one was fun and learning, and I mean, I feel like I had the tools, but some of the tools, when you really use them, you have to remember to dust them off and try it again, and that's what I did with Q4. Okay, that's what I have for this contest. 89, pretty okay, but especially since I woke up early and didn't get enough sleep. That's my story for every weekly contest because in the early mornings of 10 a.m. So, but yeah, I mean, the only thing that I'm a little bit sad about is this 5 minutes, just because I just didn't. I mean, I read it when I was doing it with the mods, but then I just ultimately did not think that much about it. Yeah, that's all for this contest. Thanks for watching, and hope you had a good contest. Let me know what you think. Which one was your favorite problem? Did you have fun with Q4 like I did? I will talk to you later. Bye bye.